Okay, section 6.1, number 49, we're given the function that is not one-to-one. F of x equals x plus 5 squared, quantity squared. And we're asked to determine a domain restriction that we can put on this function so that we can find the inverse and so that the whole range is still preserved. So let's think about what this function looks like. So this is in the parabola family. So it looks something like this, kind of, a little more curvy than that. That's a little better. And it's been that plus 5, that's with the x, means I shift left twice. So shift left 5 units. So I'll just take that and shift it 1, 2, 3, 4, 5. So now the vertex is at now that vertex is at -5, 0, and it's going up to infinity. So the range needs to go, so I can see our range of our original function. I don't want to change that. I want the range to still be preserved. So the original parabola has a range of starting at y equals 0 and going on to infinity. So actually I could just say that as y is greater than or equal to 5. In interval notation, I could write that as, 0. As 0 to infinity. So two different ways to write it. I think this is more of what your book is doing. So the range, I want to preserve that. So what domain could I choose so that I make sure I go from that minimum 0 and up to forever? So let's say we could either pick half of the parabola on the left or the right. I'm going to go ahead and pick the right because I like going left to right for some reason. Okay, so if I pick just that as my domain, then my domain now starts at -5. So my restricted domain, the original function, the parabola, has the domain from all of real numbers. But my restricted domain, I'm only going to take the right side of the parabola. So that starts at -5 and goes on to forever. Or that other notation is x greater than or equal to -5. I think this is going to be more of the notation that we use. Okay. So now that we've had that restricted donation, now we're looking at that red graph, and now we're going to find the inverse of this. So let's change colors to purple. So if my original function is f of x plus 5 squared, and the domain restriction is that x is greater than or equal to -5, so I need that as part of my function definition there. Then the inverse means I'm going to first change the function notation to express it as y. And then I'm going to draw a line because I like separating when my y's and x's change. So my next step here is let me write those first two steps. Okay, so the first thing we do is make sure it's 1-to-1. You have a 1-to-1 function. And since we did that domain restriction, the function on that restricted domain is 1-to-1. So check, that number 1 is done. And then the second thing we did was interchange the x's and y's. I'm sorry, no, we're going to rewrite the function notation as y. So you get y equals x plus 5. And now the third step, this is where it sometimes gets confusing because your x's and y's change on the same page. That's why I like to draw that kind of line so I know that when I'm in this blue box, I'm talking about the inverse. So I'm going to interchange y and x. Just kind of switch them around. So now I'm talking about my function inverse, not my function anymore. So in this blue box, I'm going to note that that's how x equals y plus 5 squared. In class, I know I did little primes on those to indicate that it was a function. I'm just doing a little bit differently here. Just any way that you can note to yourself that you've already interchanged the x's and y's so you don't confuse the two equations. Okay, so that's step 3, interchange my y and x. And then step 4, we'll do in green, will be to solve for this new y. So first thing I got to do is get y by itself. First thing I need to do actually is get the whole y term by itself, which means I need to take the square root of both sides. So we'll do square root of x equals the square root of y plus 5 squared, which gives me just the y plus 5. And now solving for y, I get y equals radical x minus 5. And my last step, we'll do an orange. Step 5, rewrite in function notation. But it's not f anymore, now it's f inverse. Or if you want to rename it as g, then that is okay too. So f inverse equals radical x minus 5. Okay. So I'm just making sure we did everything. So part A was to determine the domain restriction and preserve the range and write both of those, which we did. And then find the inverse and state its domain and range. So we still need to state as the domain and range of this. So let's do that in brown. Okay, so the new domain, it actually just swaps these. If you remember, the inverse swaps your domain and range. So the range of the original function was y greater than or equal to 0. So the domain is going to be y greater than or equal to 0. And the domain becomes the range. And our original domain was x greater than or equal to negative 5. So now the range will be x greater than or equal to negative 5. And you can look at this function and make sense with that too. So I did a kind of shortcut by using the original function, just swapping the domain and range. But if you look at this function, you can see that x is defined. Whoops, I switched my y and x's, sorry. X is the domain and y is the range. So the domain is defined by this guy. You always have a positive number under a square root. So for real numbers. So that's my domain, and then this is a parabola. So if I look at this graph, then I will find that the y values start at negative 5 and go up.